Hello, everyone. I know you're excited to get going with scripting. So first, what is a shell script? A shell script is a file of executable commands that's been stored inside of a text file. And when that file is run, each command is executed in sequence. Shell scripts have access to all the commands in the shell. We've started to look at some of them in class so far. But the real beauty of a shell script is you also have access to conditional logic. And here is the real power of scripting. A script can test for the presence of a file, or look for particular output, or test that a condition exists or not, and then change its behavior accordingly. A script can execute a series of commands inside of a loop, so they're done over and over again. And a script can accept input parameters. So one can build some user control into the execution of their script. Building commonly repeated jobs into scripts is just smart business. Once a scripter's worked out the logic or syntax for a job, or a system administrator has worked out what commands need to be implemented to back up files, clean up directories, and so forth, why should those commands need to be typed again and again with each new run? It's only smart business to package those things into a script. And so we will start by writing in the computer lingo the traditional first script, hello world. So we see our Linux Mint desktop in front of us. Of course, you can also use some other virtualized Linux environment. I will open up the terminal to appear for me the command line interface. I'm in my home directory. I've created a personal bin directory just for convenience sake and organization. So using the VI editor, I want to create a script called hello world. And because it's a shell script, I'll just give it this .sh file extension. Now, that's not necessary because remember in Linux, there is no file association concept. This is for me, the human being, or any others that might come across the file. The first thing about scripts in Linux is that the operating system itself needs to understand what kind of a script I am proposing. And so that is done with what is called the hash and bang character. These two characters, the like tic-tac-toe sign or hash and the exclamation point or bang, is a way to notify the operating environment what command interpreter that I want to use for this script. And this symbol is sometimes fondly called shebang. Okay? So the shebang, when they're at the head of the script, indicates the shell or interpreter that should be used to interpret the script. We are writing our scripts for the bash shell, so we always are going to start our scripts here in this class with shebang /bin/bash. Scripts can have blank lines in them for readability, so I will just go down one more line and issue our very first command, echo. Echo takes some text that we can put in a double quote and merely will echo or send back out to the screen that text. So this is going to be our entire first script. Now, will this script run? Well, let's try it. Permission denied. Well, let's look at Hello World. We can see that in the permission mask of the long listing, there is read and write execute for the owner, and then read only for the group, and also read only for everyone else. So in order for this script to run, we need to add an execute permission. Now at this point in the process, we're going to do it the very quick and dirty way by saying chmod space plus X and then the name of our script. Okay. This will add execute permission for everyone. And we can see that this is indeed the case when we do the long listing a second time. We see those X's for every position. And because it's Linux Mint, there's the color coding that had turned the output green, and that indicates it's an executable script. Well, let's try again. Our script has done exactly what we asked, to echo the words hello world to the screen. Now, this may or may not work in your environment. You may get another error message about the script not being found. Now, why would that happen? Well, let's look at the path variable. My path happens to have that home NOS 120 bin directory right at the beginning of the path. If my path did not have that, you know what would happen. The operating environment would go in order from left to right through all of these directories and never find my script, and that would be a problem. So I've solved that problem myself by putting my personalized bin directory right at the beginning of the path. If you do not have this condition true, you can always run your script with the // in front of it, which means start right here in my current directory and look for the script name that I enter, and that will be sure that your script is found. Okay. So you have had a little bit of practice with the VI editor, and I hope you are beginning to feel comfortable with it. For really, really short scripts, you could still use the cat method, which you will recall from the very beginning of your Linux work. But I really urge you to start using VI. And remember, you have 4 ways to insert text with VI: before the cursor, after the cursor, the line below the cursor, and the line above the cursor. And that escape key is always the way that you exit that insertion mode and go back to command mode. So one of the best ways to get going with scripting is to, hey, write a script. So let's imagine that we have a problem. That's always a good way to start. Say we have to write a shell script that displays the time on our screen every 15 seconds, and we want to display that time in our local times 12-hour clock format. Okay. So we're given that specification, and we need to turn that into some scripting logic that will complete those requirements. So let's see. I will name the script time display and give it that .sh suffix. What's the first thing we need to do? Shebang, bin bash. I'm going to hit the I key on my keyboard to enter insert mode. Shebang, bin bash. And then, I want to display the time in this 12-hour clock format. And the specifications actually say, well, let me do this forever. Don't say when to stop. So I can use something called a while loop. And there happens to be a special condition in the Linux script called true, which always evaluates to true. And everything inside this loop is embraced by do and done. Okay. So while true, do a bunch of stuff. Okay. So I'm going to hit the escape key on my keyboard now to get out of that insert mode so that I could move around in my script without actually entering any text. Okay. And in fact, I'm going to see the colon at the bottom, WQ, write and quit. Okay. So clear the screen. Okay. So that script isn't finished, but I need to do a little bit of research before I finish that script. 2 things. This every 15-second requirement, I need to do a little research on that. And having the time display in this local 12-hour clock format, there's got to be an easy way to do that, and I'm going to find out. So In one of our previous assignments, we used a command called sleep, and we knew that basically allowed the system to rest for a certain amount of time. So let's look at the man page. Man for sleep. So sleep has a delay for a specified amount of time. And oh, look, lucky for us, this number is a number of seconds. So I can meet the specification of displaying the time every 15 seconds by just using this sleep in between display times. Okay. We've seen the date command, and the date includes the time. We can see, according to my clock on the wall, that it's 2:21 in the afternoon, and that is built right into the time from the date. But alas, that's a 24-hour format, and it has a lot of extra stuff in there that I don't actually need. So let's look at that man page for date to see if we can tweak that command and make it work for us. Well, let's see. Locale. Oh, there's some interesting information on the abbreviated weekday, full month and day. Date and time. Percent and a little r. The locale's 12-hour clock time. I think that'll do it for us. Let's go back to the command line and give that a go. That should do it. Now we have the time displayed in the 12-hour time. The 12-hour clock. All right. I think I've got some things that are able to get me going now. So let us go back and find that script that we were working on, time display. And I'm going to hit I to go into insert mode. And I think I'll want to clear the screen each time through the loop. Do that. Indenting isn't mandatory, but we'll just try to make it look neat. Use the exact format that we had used at the command line, and sleep 15 because it said that was 15 seconds. All right, so I can get rid of an entire line in VI by hitting the D key 2 times quickly. DD. You saw the whole line went away. Okay. Now I'm going to leave insert mode by hitting escape on my keyboard. And I can either write quit, like you see down at the lower left, or another way to write and quit automatically is use the shift key on your keyboard and ZZ, the Z key twice. This automatically writes and quits. All right, So we have a script. Again, it is not executable by default. So we have to change mode to add execution ability. And then to execute it, I will do it the way that you will probably have to do it. Say right here, / and time display. And now every 15 seconds, we should get a new time on our screen. And we see it flip from 26 seconds to 41 seconds. So that's 15 seconds. The next number of seconds we should see would be :56. And we could just sit here all day and watch the time go by. We'll let it flip one more time and then break out of the program. Okay, so I'm going to hit Control and C on my keyboard to break out of that program. So that was a little script that we had to do a little bit of research to find out some Linux commands that would help us meet the specification, and then we packaged those together into a reusable script. How about now we write a script that displays the names of all directories, but not the files in the working directory, whatever that working directory might be. So right now, how about if I make a directory and we'll make it Wednesday. So now we do have a directory named Wednesday just for testing purposes, and I will write a script finder.shell, and it always starts with shebang bin bash. If you want to put a comment on a line, this script find directory file name in the present working directory. You can do that by putting a single hash at the beginning of the line and then follow that by text. That will be seen by the interpreter as text that is not to be executed in any way, shape, or form. So we can actually do that just for empty lines as well. So say I want to do ls. I can use that pipe like I used on the command line. And then a while statement. I'm going to read a variable. We'll call that variable x. And then the same do and done routine that we had done before. Okay. I'm going to go back up here and add, what is it I want to do? I want to test that variable to see if it is a directory. Now, we're going to find out that there's this test command that's really powerful, and I encourage you to look at the man page for test. You can test whether a parameter you pass in is a file, a directory. You can use test for seeing mathematical relationships between a variable and a constant. So we'll look at test some more. Right now we'll just use that test feature for this test of the directory. So we're going to say if the item coming in from LS, we're going to read them one by one. And if it's a directory, then we're going to echo out just the name of that directory. And all if statements end in this funny ending, FI. And we already have done for the while loop. And now I'm going to make sure I hit escape so that I'm out of insert mode and back to command mode and do that shift ZZ. Again, we'll look and see that we need to add execute permission. And go ahead and run the script. And indeed, we only have one output from this program, and that is the file that happens to be a directory named Wednesday. If you were interested in seeing what happens for everything else that's not the directory, you could echo out no directory here. And actually put some extra space in there for formatting. And let's go ahead and run that again. And we can see that every file in the LS came through, but only Wednesday was a directory. So I'm going to cat that to the screen so that you have a minute to look it over if you are interested in examining what went on with that particular script. And I think I will stop there for now, except for one final look at the man page for test. And you can see that test just takes as an expression as its parameter. That expression can be inside of these hard brackets. And all kinds of explanation about what can be in that expression. And we will look at the one that I just used, -D, and then a name. And then it says that that file exists and is a directory. So I use that capability to find out whether each file or each listing from LS was or was not a directory. So always use the man page. If you're not sure whether a certain command will work for you or not, sometimes you just have to do a little research and experimentation. And I'll be coming back soon with more examples for you on writing a script.